Okay. So we're going to learn about these nuclear equations now. So carbon-14 has decayed into nitrogen-14 and it's produced a particle called a beta particle. It's done it spontaneously and unpredictably or randomly. So the question is how it seems like these numbers don't add up. Well, let's remind ourselves that these atomic mass, it adds up to the protons and the neutrons, right? And this one is just the protons. So this atom here has 6 protons. This atom here has 7 protons. Okay, it does sound like somehow a proton has just appeared from nowhere. But and to be honest, beta radiation is the more kind of, or beta decay is the more mysterious of the three really. So let's just make sure we understand what's going on here. We've got 6 protons, and we've got 6 and 7 protons on the left. Sorry, on the right. So I'm just going to shrink that a little bit so there's a bit more space. Okay, yeah, that's fine. So can you work out how many neutrons the one on the left has and how many neutrons the one on the right has? Right, so 8 neutrons, 7 neutrons. So remember the mass number, this stayed the same. So oh, well, you've basically just answered your own question, really. Well, that is what happened. So a neutron turned into a proton inside this atom here. A neutron just changed into a proton. So that's weird, really, isn't it? And they would like you to realize that that's weird because it doesn't just turn into a neutron. It also produces this beta particle. But this beta particle, when we look at it a bit more closely, we find out that the beta particle is an electron. So, and we'll do a little minus sign there, usually for electrons. So really what's happened is in all beta decay, a neutron, actually I would say in all beta decay at GCSE, okay, a neutron decays into a proton and an electron. Okay, now yeah, the electron is what we call the beta particle. We call the electron the beta particle. So they maybe when they first discovered these beta particles, they didn't realize what they were, and then after a while they did. What they would like you to say in the GCSE is that in your exam is often when they say what is a beta particle, it's a 2-mark question, and the first mark will be it's an electron, and the second mark will be saying it came from the nucleus, or they'd accept. I presume I would have thought they would accept a neutron turned into a proton and an electron. So that's kind of weird that happened. When we understand what was going on, though, it's not too hard to be able to predict some of these things. For example, if I knew it was beta decay and I didn't have any of these numbers, let's use some shapes to cover this up, so we can imagine what kinds of questions they could ask you. Whoops. So let's just cover some of these numbers up. In fact, if I could cover up all of that like that, and if it said ask you to complete the equation, well, you would know that because it's beta decay, you would know that the mass number would stay the same, and you would know that a neutron turned into a proton and an electron. That's the electron. So we would know the atomic number would go up to 7, And so that means it must be nitrogen, and so you'd be able to do the question like that. Or if it just told you some of the other things, like it's nitrogen, and they didn't tell you the mass number, maybe. Oops. Oh, hang on. So let's say they just told you it was nitrogen. Maybe they didn't even tell you that it was a beta particle. Well, you'd be able to work that out because the carbon went into nitrogen, which meant the atomic number went up by 1. And so the only way that could be would be with beta particle. So that is one way of trying to work these out. I'll keep this rectangle for the next type of nuclear decay. In fact, I'll cut that video at that point. That's radioactive. That's a nuclear equation for beta decay, and we'll look at alpha decay next. Okay.